3.1 we talked about measures of central tendency. That was one way to kind of get an idea of what was going on with the data. Mean, median, mode, mid-range. Those are all sort of middle numbers that give us some information about the data. Okay. What it doesn't tell us is how spread out or how bunched closely together the data is. And that's what variation is. Variation or variability is how far apart from the mean our data is, how spread out the data is. Okay? And we're going to go through some examples so you can kind of see the differences in data sets where they actually have the same mean, but they clearly look a little bit different. And so we're going to go through some definitions first, and then I'll walk you through how to do some of this. Okay? So this is what we're talking about in 3.2. Another way to analyze statistics is how spread apart the data is. And that's what variation is all about. Variability. How far apart is the data? So the range, we've talked about range before. Range is actually one number. It's the difference, so subtracting between the highest and lowest value. So that's just telling you how far from beginning to end, when it's in order, the data is. A range can be used a little bit to help us determine how spread out data is, but it's not entirely useful because of what's called an outlier. An outlier is a type of number that really doesn't fit with the rest of the data at all. It's either way bigger than the rest of the data or way smaller than the rest of the data, than the majority of the data. So the outlier can affect the range in a significant way if there's an outlier. And so then that makes the range not as useful to us. If there are no outliers, the range can be a little more useful because it kind of gives you the entire spread of the data. Okay, so you just have to be careful with that because of outliers. So the two more useful quantities that we're going to look at that help us evaluate spread are variance and standard deviation. Okay? They are closely related. Variance and standard deviation are ways to determine how spread out the data is from the mean. Okay? Variance and standard deviation. I'm going to show you why those two are so closely related here in a second. So, here's what you need to know about the variance and standard deviation. The bigger those numbers are, the more spread out the data is from the mean. And these numbers are relative, okay, depending on the data. So the bigger the variance is, the bigger the standard deviation is, the more spread out the data is from the mean.
Why do you need to find out how spread out it is?
We'll talk about that. It's a good question, and we will talk about that. Okay, the converse is also true. The smaller those numbers are, the less spread out the data is from the mean. So the question is, Anthony's question is, why do we care? Why do we care how spread out numbers are from the mean? Again, with statistics, we're trying to make a conclusion about the data in some form, depending on what the study is, okay? And you're looking for trends. So if the data is really spread out from the mean, meaning it's really spread out, period, the people that are being surveyed or the study, the experiments, the data that's being collected, you're not seeing a trend because it's kind of all over the place. But when it all seems to be clustered and bunched, that can tell us more about trends. So the smaller the standard deviation, the smaller the variance, the more likely we can make a conclusion about what's actually going on in the study versus not being able to draw a conclusion because the data is really spread out. That's kind of the gist of it. Let's look at a set of data. So if you want to take a picture of that, okay, because we're going to talk about this data in particular here, and you're going to be entering that into your calculator in a minute. Not yet though, but go ahead and add that to your notes. If you notice, and if you want to do the calculation you can, or you can just trust me, the mean for both of these data sets is exactly the same, okay? And so obviously the data is different, but the means are the same. So the reason we want to look at variance and standard deviation for something like this is to help us understand how closely or far away the data really is from the mean, because that again gives us a better analysis tool. Okay, so I'm going to show you how to enter this in. We're going to calculate the standard deviation and the variance using our calculators. Now I want to talk about a little bit first what variation or variance and standard deviation actually is. Okay, and I want you to think about it in terms of distance. And if you think back to when you had to do the distance formula for 2 points, right? You had to subtract the x's and square them, and then you added the difference between the y's and you squared them, and you added those together, and then you took the square root of the whole thing to find the distance between those 2 points. In a lot of ways, variance and standard deviation is similar. Instead of So I'm just explaining the formula to you a little bit. You're not going to need to know. You're not going to ever have to do the standard deviation or variance by hand. Okay, so that's the good part. But let me explain the formula to you a little bit. It's really like taking the data set and finding the distance between the data set and the mean. And so if you can think of those ideas like subtracting a data point by the mean and then squaring it, like we do with distance, it's the same idea, okay? What the standard deviation really is the total distance away from the mean. And so the smaller that distance, the closer it is to the mean, the more tightly bunched that data is. So the reality is what you do when you actually calculate the standard deviations, you subtract each number. You subtract the mean from each number, and then you square that and add them all together. That's the variance. When you take the square root of the variance, you have the standard deviation. Okay? So that's what variance and standard deviation really are. Okay? Here's what you need to know. The standard deviation is the square root of the variance. So again, think about distance. When you find the distance, when you use the distance formula, you take the square root of those differences of squares. Okay, what's underneath that square root is the variance. Conversely, the variance is the standard deviation squared. And this is the one that you're going to use more than anything, okay? Because our calculators actually don't give us the variance. They will give us the standard deviation. So in order to find the variance, you're going to have to take the standard deviation that the calculator gives us and square it. Okay, so we're going to use a graphing calculator to find these values. Again, it will only give us standard deviation. We're going to need to calculate the variance right here. And then you have to know that there's a sample version of the variance and the standard deviation, and there's a population version of the variance and the standard deviation. Okay, and the symbolism is a little different for the sample versus the population, and I'm going to show you all that different symbolism. And then there's a slight change in the formula, and I'll explain that. But again, you're not going to need to know the formula. You're not going to ever have to calculate it by hand in this course. But I want to show you the difference between each, and depending on the problem, sometimes the problem will ask for, well, they'll tell you this is the population data, calculate the population variance and standard deviation, or it'll tell you it's a sample, or it will tell you neither, and you actually have to find both. So pay attention when you're working through the problem as to what the work actually is. And I'll show you all the different symbolism next. So here we're going to break this down into the population column and the sample column. Don't take a picture yet if you're going to take pictures, but actually I want you to try to write this out anyway. I want you to try to write out some of these Greek letters. Okay? This letter here is called a sigma. This is actually a lowercase sigma. It means standard deviation for population. Obviously, with it squared, the variance is the square of the standard deviation. So this lowercase sigma means population standard deviation. This is an uppercase sigma, which means sum. And if you recall, the mu is the mean. So all this is saying is subtract the values minus the mean, square it, add them all up, divide by the number of numbers. Okay? That's what the population variance is. And again, I want you to recognize these things, write them down, but you're not going to have to actually do the calculation itself.
Wait, so how do you spell mu?
Just write the little mu.
Oh.
Just write the little symbol down.
You know, I'm trying to label it.
It's sort of like a U with a long front. It's sort of like an M, really. It's sort of like a superscripty M. So each of those little parts that look like they're forming the U are actually the peaks of the M. Okay, so this is what population variance looks like. Sample variance, a little bit different. Okay, sample variance, we just use the letter S. And remember our symbol here for sample mean, X with the bar over it. Now one of the differences, instead of dividing by n, we divide by n minus 1. Okay, and so what we're accounting for there, since we divide by 1 less than the number of numbers, we are going to get a bigger number. We're accounting for error. So whenever you divide by a smaller number, you take some big number and divide it by something smaller, you're dividing it into bigger pieces. And so we divide it into bigger pieces to account for the fact that we don't have all the data. So again, notice the differences. There's a couple differences. Sigma we use for population, S we use for sample. Mu is the population mean, X with the bar on top is the sample mean. So those are two differences. Then we divide by the number of numbers in the population. In the sample, we divide by the number of numbers in the sample minus 1. Okay. Now, the actual standard deviation for each, okay, is just the square root of all that. Okay, so the square root, sigma, the square root of all of this. And that's, of course, equals the square root of sigma squared. And again, that's this relationship. Sigma is the square root of up here, and then for the it's the same way, okay? It's the square root of all of this. I'll let you catch. So again, key thing here, what's under the square root is just this. What's under the square root is just this. So again, that's that relationship between standard deviation, sample standard deviation, sample variance. Population standard deviation, population variance. Okay? That relationship is just taking this and squaring it will give me this. Taking the standard sample deviation, the sample standard deviation, and squaring it will give me the variance. That's the relationship. And the standard deviation is what we're going to spend most of the 3-2 focusing on, but we're going to look more at that on Thursday. Yeah.
If you square root and square the x, isn't it just the same?
No, you're doing the difference first. First of all, okay, so let's talk about what it is. Okay, so Anthony's question, isn't this just, this is x in both of these represents each individual data value. What the variance is actually doing is you're taking the difference between the data value and the mean. The data value and the mean. Okay, and you subtract them in that order. And what ends up happening is if you didn't square the numbers and you added them all up, it would always equal 0. Because the mean is calculated from adding all the numbers up and dividing by the number of numbers. if you just subtract those values, because of the number of numbers, it will always give you 0. And some will be positive, some will be negative. So what we do is we square them just like when we do the distance formula. We take the difference in the x-coordinates, square them, add it with the distance in the y-coordinates, square them, and then we take the square root of that whole thing. It's the same idea here. You take each individual difference between the data point and the mean, add them all up, or square them, add them all up, and then to find standard deviation, you take the square root of it. So it's the same sort of idea, okay? So conceptually, that's what's happening. You're trying to figure out, again, how far away the data points collectively are from the mean. And the further away they are from the mean, the bigger your variance and standard deviation will be. The closer they are to the mean, the smaller the variance and standard deviation will be. Now, let's go through and we're going to find the variance, the range, and the standard deviation for both sets of data, for A and B, just to kind of show you, like we already know, okay? So here's the same set of data, okay? We're going to calculate the range, population, and sample variance, population, and sample standard deviation. See, here's the thing. The reason I chose this data is simple, okay? One, I wanted to use one that had the same mean. Okay, which column is more spread out, A or B? Okay, so A is definitely more spread out, and so all of these values should show me that A has higher range, A has higher variance, A has higher standard deviation, and conversely, B should have a smaller range, should have a smaller variance, should have a smaller standard deviation. So go ahead and find the range, okay? That you don't need a calculator for. Okay, range again is the difference between the highest and lowest number. So go ahead and do that, and then we'll talk about how to find the variance and standard deviation in your calculator. So really what you've got here is sort of our setup, okay? These are all the things I'm going to find for A and for B. So I've got the range for A and B. I've got the variance. This is the population variance and the population standard deviation. This is the sample variance and the sample standard deviation, and then the same thing over here. So right now I just want you to find the range, and then I'm going to help you through doing variance and standard deviation on your calculator. All right, what is the range for A? Range for A, 50. How'd you get that? 60 minus 10, that's 50. Okay? The biggest minus the smallest. What about for B? 20. 45 minus 25. Okay? So based just on the range, what we should see, okay, is it's verifying our claim a little bit. A is more spread out, B is more spread out. There don't seem to be too many outliers, but in brand A, you could almost say that 10 and 60 were outliers. It's hard to say because it's really kind of evenly spread out. Okay, so the range isn't a bad variable to look at here, but we're going to verify the closeness or the spread for A versus B here in a second. Now, here's what you have to do. Okay, here's what I want you to do. In your calculator, make this. I want brand A to be list 1. Oops. So this one is going to be list 1. This one is going to be list 2. Okay, so I want you to just enter that data. Oh, one other thing. I know some of you keep deleting your lists. If you're trying to empty your list, hit the clear button. Don't hit the delete button. Hit the clear button and it will go away. If you hit the delete button, you'll actually delete the whole column and you'll lose your list number. Okay. Go to the top. If you want to delete the whole, if you want to clear the whole column, go all the way to the top and highlight L1. Now hit clear and then hit enter and it should go away. So you can delete your whole column just by going up to the L1, highlighting it, hit the clear button, hit enter, and that whole column will go away. Instead of just replacing it every time. Keep in mind, this is the same data that we had a few slides ago. I just made it smaller to all fit on the screen. Okay. Now, because each of you have a different model to some extent, some of you have the same ones, some of you have older ones. The steps to calculate the standard deviation, sample, population, and variance are going to be a little bit different in terms of mechanically typing it into your calculator. And mostly it's because you have to tell the calculator what list to do the calculations from. So because we have both entered in, we're going to have to tell it when I'm looking for brand A, when I'm trying to fill all this out, you're going to have to tell your calculator to do the calculations from list 1. When you're wanting to do brand B, you're going to have to tell your calculator to choose from list 2. Okay, does everybody have the data? Anybody not have the data in yet? Okay, good. So in order to allow your calculator to do the calculation for you, hit the stat button and go over to calc for calculate, and you'll notice the very first thing that is there says 1 var stats. That means 1 variable statistics, and since we're just doing a column with 1 variable, that's the one you want to use. So hit enter on that, and then depending on your calculator, you'll get one of a couple different screens. Okay. If you have one of the newer calculators, just make sure that the frequency list, the second one down, is blank. We're not doing frequency list. All we need to do is on the first one have list 1. On the older calculators, what will happen is it'll take you to a screen and it will just say 1 var stats. Next thing you need to do is tell it what list to choose from. So now you got to put L1 in. So L1, I think you have to hit the second, yeah, okay. And so now once you're there, just on the older calculators, hit enter. On the newer calculators, hit calculate. Anybody having issues with that? Okay. Now on that screen, now it's giving you a lot of information, okay? It's giving you the mean, it's giving you the standard deviation, it's giving you the sample standard deviation, it's also giving you the population standard deviation. So now what I want you to do, since we're doing list 1, we're filling in over here, okay? So write in the population standard deviation that it gives you, and as a general rule, we go 1 decimal place beyond the data. So in this case, because the data is to the nearest whole number, you're going to go to the 10th place, 1 decimal place is what I want you to write. I know your calculator has given you more, but traditionally, we just go 1 place more than the data.
That's OS on the calculator.
That's a sigma.
Sigma X.
Sigma x, yep. So the sigma x is sigma, okay? The calculator just puts the x in there, you don't need the x. And that's why where I've written it on the screen here, the sigma is the population standard deviation. The S is the sample standard deviation. Now, like I said, it doesn't give you the variance. You're going to have to calculate the variance. So, here's what you should have gotten. You should have gotten for sigma population, you should have got 17.1. And for the sample, you should have gotten 18.7 for the standard deviation. How many had that? Again, it's 1 place more than the data. Now, here's where I'm going to tell you to use as many places as possible. Okay? Because the calculator doesn't give us the variance. Again, these are the variance. This is the population variance. This is the sample variance. What I want you to do is take as many decimal places as you can and square it. So you're going to have to take this 17 point whatever it was, take as many as you can, and square that for the variance. Okay? And so you'll have to go out from that page. So you probably want to write that number down and put it.
So we don't want to just square 17.1?
No, I don't want you to square just 17.1. Okay? I want you to actually square as many digits as you can. But when you write the standard deviation down, and when you write the final answer for variance down, it will only be to one decimal place. But the reason, of course, that we square as many digits as possible is to improve our accuracy. Okay? So go ahead and do that. Okay. So here's what you should have got for the variance and for the population variance and for the sample variance. Okay? So it comes out, for the sample, it comes out exact. Yeah. Choose. Alright, now do the same thing for list B. So, or for brand B, which is now list 2. So you go through the same process, but you have to tell the calculator which list to choose. So when you go to stats and calculate in one variable statistics, you just have to make sure that you tell it to select from list 2. Okay, so take a look at your screen. And again, let's get back to the whole point of this, right? We already established, again, for this set of data, it was easy to tell that there weren't very many numbers. We could tell clearly that brand A was way more spread out than brand B. But these numbers verify that, okay? Relatively speaking, the standard deviation, sample or population, is much smaller than it is in brand B than it is in brand A, as we would have expected. This data is more spread out. This data is bunched more closely together. Okay, and the standard deviation and the variance, as I indicated at the beginning, the bigger the number, the more spread out the data. The smaller the number, the more clustered the data is, and that's really the kind of the gist of the whole thing. Now, once we get there, okay, that's one way to do this. Enter it in, good to go. We're also going to have group data that we're going to have to worry about, okay? And so what I need to show you is how to do those calculations from group data, and the steps are much more involved. They start off similarly with needing to find the midpoints, but then the rest gets a little more involved and you have to make a little table. And I'm going to walk you through an entire example. All right, so now I'm going to put these formulas up here.
Can we just take a photo of that?
In 1 second. Yeah. So when we look at group data, we're going to look at sample. Okay? So yes, please take a picture of that, and I'm going to walk you through what all of this means. So again, we have this frequency table. So again, what we're going to be doing is we're going to take this frequency table, we're adding these columns to allow us to create and find the standard deviation and the variance using this formula. You are going to have to follow this formula. So this is one that's kind of important. All right. So go ahead first and find the midpoints of all the classes. Fill out this column right here. The midpoints of all the classes. And once you find the first two, you should see the pattern and be able to move along and fill the rest of that column down pretty easily. The midpoints of all the classes, and then fill that in. Once you get the first two, you should be able to fill it out and see the pattern. Okay? So here's your midpoints. Double check and make sure you got the right set of midpoints, okay? Again, once you go through the first two, you should be pretty confident that you know it's going to go by 5. Okay? And in fact, these go up by 5, the midpoints go up by 5, okay? So now here's what we're going to do with the rest of this table. Okay? So this means frequency times the midpoint. So go ahead and fill this column out. Frequency times midpoint. See, we need that right here, the frequency times the midpoint. That's one of our columns that we need. Again, keep in mind your notation. X sub m, that's midpoint. F is frequency. Okay. So here's the column you should have got for frequency times midpoint. Again, all you're doing is multiplying these two numbers together to get this column. All right. Now the next one, what you have to do is square the midpoint first, and then multiply it by the frequency. So the first one, 8 squared times 1, right? The second one, 13 squared times 2. So square the midpoint and then multiply it by the frequency. Square the midpoint first, then multiply it by the frequency. All right, just because we're running a little short on time, there are the values. Okay? Now, here's what we need to do with those values. Okay? So notice in the formula, we have two different things. One is we have the sum of those values. So that's this. So this part here is the sum of these values. The second part, you have to take all of these values, add them up, and then square it after. So I need totals for each of those columns. Okay, and that's what I have here. So again, the total for the frequency times the midpoint, the total of the frequency times the square of the midpoint. I need both of those because they're each going to go into our formula. This one is going to go in here, and I sort of highlighted it on the next screen, I think. Yes, I did. Okay, so notice where I highlighted it all. Okay, so the greens line up, the yellows line up. Okay, and then I just plug it into the formula. So notice here, n, there's 20 numbers, so I have to total these up. So that's what my n is. So anywhere that there's an n, I put a 20. The sum of the frequency times the square of the midpoints, that's this, goes in here. The sum of the frequency times the midpoint goes in here, and it gets squared. That's why the squared's on the outside. Okay. Now, I'm not gonna have you input that because we don't have enough time. All right, but just know here's what that calculation is. That calculation gives me 68.7. So that's the variance. The sample variance for this group data is 68.7. How am I going to find the standard deviation? I have to square root this. Okay, so that's the bottom line. I just square root this, and I end up with 8.3. Those are my final values. Okay.